Right. Okay. So let me share the screen. Okay. Now the first question. The first question is there is some kind of adjustment need to be done. I couldn't mention that one during the paper. The first question is if the density of methanol is 0.793 kilograms per cubic decimeter, what is the volume needed for making 2.5 cubic centimeter of, you correct this one as, of 0.1 moles per cubic decimeter solution. Right. So this is the question. Correct it as like this. If the density of methanol is 0.793 kilograms per cubic decimeter, what is the volume needed for making 2.5 cubic decimeter of 0.1 moles per cubic decimeter solution? So the methanol is CH3OH. Now, first of all, you need to find out how much of moles is needed for this requirement. The concentration is given and the volume is also given at the end result, the solution that you need. Then you can calculate the number of moles that is needed, right? So you can say number of moles needed. We can say that is 0.1 within 1000 cubic, and this is in cubic decimeters, obviously. So this is within 1 cubic decimeter. We can say like that. Then how much is needed for 2.5 cubic decimeter? That means how much of moles will be there within 2.5 cubic decimeter. So we can say that is 0.25 moles. So this much of moles is needed, right? And also on the other hand, we can say, or we can find how much of mass is needed for the mass of methanol we can find out from this calculation, right? Because the number of moles is known, the mass of methanol can be calculated. Why we calculate the mass of methanol? Because it is given as the density, because 1 cubic decimeter, how much of the mass is there for the methanol. So that is the variable that is given in the question, right? So in this manner, we can say mass of methanol. We need to find out the molecular mass of methanol as well. So mass of methanol can be calculated by multiplying moles by molecular mass. So this is 0.25 moles. CH3OH. CH3OH means like carbon is 12, hydrogen is 4, and this is 16. So altogether, we can say this is 32. So this is multiplied by 32 grams per mole. So this is like 0.25 means 4. This is 8 grams. Now 8 grams is needed for this one. Only just 8 grams is needed for this one. So the density is given as the mass of 1 cubic decimeter is 793 grams. So this is within 1 cubic decimeter. So therefore, volume required for 8 grams, right? So we can calculate. So 793 grams is within 1000 cubic centimeters. Then how much of volume is needed for 8 grams? So in this manner, you can calculate the volume that is need to be taken for this required solution. Now let's say the volume is like, for an example, if you do this math, the volume is like a y. Then you calculate or you measure this one. You measure this y cubic centimeters from the solution and add water until solution becomes 2.5 cubic decimeter. So this is how the solution is prepared. You take y cubic centimeters, then you have the required number of moles, take it out, then add water until the total volume becomes 2.5 cubic decimeters. Right. So that is how you prepare this given solution. Right. So this is how you do this question. There is an error in the question. The error is the concentration is not given. The concentration is 0.1 moles per cubic decimeter. If I summarize this one, how to do this one? First, find out the number of moles that is required for the final solution. Then calculate the number of moles. Calculate the mass. Then, in order to take that mass, how much of volume need to be taken from the original solution? Because the density is provided for this one, right? So, since the density is provided, you can calculate the volume needed to be taken from the initial solution or original solution, right? I hope there is no questions on this one. If there are any questions, you can ask me. Let's go to the next one. If you need some time to copy this down, I will give you a few minutes. Then the next question. 250 milliliters of 1.5 cubic decimeter, 1.5 moles per cubic decimeter solution, H2SO4 is diluted by adding 5 liters of water. What is the molarity of the diluted solution? Right. Now, here, 250 cubic centimeters or 250 milliliters of 1.5 moles per cubic decimeter H2SO4 solution is diluted by adding 5 liters of water. Now the molarity means how much of moles is within 1 cubic decimeter. So you can calculate the how much of moles we are talking about here. If you know the number of moles that we are talking about, that should be the same moles within that 5 liter as well. Let's say like we have a solution that is 1.5 moles per cubic decimeter. Volume is 250 milliliters. So you can calculate the number of moles within this solution. And the same number of moles will be within 5 liter of water. Then you can calculate the concentration. Molarity means the concentration, that is how much of moles within 1 cubic decimeter. So let's calculate this N, right? So NH2SO4 in 250 milliliters. So that is 1.5 moles is within 1000 cubic centimeters. Then how much within 250 cubic centimeters? So this is 1.5 divided by 4 moles, right? So this moles, the same number of moles will be used to prepare that 5 liter. So now after that, these moles will be within 5 liters. That means 5 cubic decimeters. So molarity means how much is within 1 cubic decimeter, right? So therefore, molarity of the solution. So we can say 1.5 moles divided by 4 is within 5 cubic decimeters. Then how much within 1 cubic decimeter? So you can say like this one is 0.3 divided by 4 moles per cubic decimeter. You can take the answer as 0.037 and 5 moles per cubic decimeter. So the idea is when you add water, no change to the number of moles will be a constant, but the volume will be changing. when the volume is changing, the concentration will also be changed. Only the volume is changing, nothing is changing in terms of the moles. Same number of moles will be there, right? So this is how you do the second question. If there are any questions, you can ask me. Huh? මේ ප්‍රශ්න හරි ලේසි ප්‍රශ්න. ඔයාලට මේ පුරුදු වෙන්න ඕන විදිහට තමයි මම මේ පේපර් එකට දාලා තියෙන්නේ. After that we will be doing more complex questions. තාම ඔයාලට ලොකු complex questions වලට යන්න අමාරු නිසා තමයි මෙහෙම කරලා තියෙන්නේ. Okay. So let's move into the next question. A beam of helium atoms moves with a velocity of 2 into 10 to the power 3 meters per second. Find the wavelength of particle constituting the beam. Now here we are given the velocity, right? We are given the velocity, and also we are given it is helium as well, right? So we have been asked about the lambda. We have been asked about the lambda. Now we know de Broglie wavelength lambda is equal to h divided by mv, the velocity, or mc, right? Or h divided by momentum. Velocity is given, right? We know this one. This is already given in the question. Our only problem is finding m, right? So how to find m is, here we are talking about helium atoms, right? So we need to find mass of one helium atom. That is the challenge here. So helium is 4 means relative molecular mass of helium is 4 grams. That means if you take Avogadro number of helium atoms, the mass is 4 grams. Then we can calculate how much of what is the mass of one helium atom, right? So we can do like this. Mass of one helium atom. Why I am calculating the mass of helium atom, one atom, is because this is a beam of helium. Then the lambda will depend on helium atoms. A helium atom ඔක්කොගෙම බර නෙවෙයි ගන්න, right? So because the lambda will be decided based on the atom mass or atomic mass, right? So we know mass of Avogadro number is 4 grams. Then I will divide this by Avogadro number like this. So this is the mass of one helium atom. Okay. Then we can easily find lambda. Lambda is 6.626 into 10 to the power minus 34 divided by mass is 4 divided by 6.022 into 10 to the power 23 into V is given this one, that is 2 into 10 to the power 3. So you can calculate the lambda from this calculation. I have missed to add the units. Units should be added. So let's rewrite that one with the units. Lambda is equal to H is 6.626 into 10 to the power minus 34 joule second divided by mass is 4 grams divided by Avogadro number 6.022 into 10 to the power 23 into helium and the velocity is 2 into 10 to the power 3 meters per second. So you can calculate the lambda in this manner. So the volume, so the answer will be in meters. Okay. So this is how you calculate the this is how we calculate the wavelength of helium atoms. Yes. So these kind of questions could be asked. So therefore, better you will be aware on those type of questions also, because these are MCQ questions actually, right? Not essay type questions, right? Then you have been asked to draw some Lewis diagrams, acceptable Lewis diagrams. Let me start from C2H2, right? So I can let me share this. Let me stop the sharing first, because I need to share the. I will take this one into here. No, you can't see the screen. No, you can't see the screen. Okay, let me share it again. Right. Now C2H2. We can say the number of electrons, valence electrons, from carbon, that is total valence electrons is 6. 6 into 2, that is 12. Valence electrons from hydrogen, that is 2. Total electrons, this is 14. Electron pairs, 7, right? Then I can place these pairs together with hydrogen and carbon. I will place 1, 2, and 3. No need of hydrogen, no need of the lone pairs for hydrogen, because hydrogen is having only 1. So rest of the electrons will be placed on top of carbon atom, right? So we have placed 3, 4 is left. So I will place 2 for each, like this, right? So let's calculate the formal charge here. Carbon, we have placed 1, 2, 3, 4, 5, 6. So this is -6. 1, 2, 3, 4, 5, 6. So we will place -6. Sorry, -2. Very sorry. All together, there will be -2. We have placed 6. Additionally, 2 electrons has been placed. So what shall I do is, I will place a dative bond from here to here. Then there will be transition 1, hydrogen, carbon double bond. Then there will be like this, right? Then the formal charges will be here, that is -1. Here this will be sorry, I have done a mistake from the beginning here, I think. Here carbon is, sorry, let me do it from the beginning. There is some mistake that I have done. Carbon is 4, because there is 4 electrons here. That is the mistake that I have done. This is 8. This is 2, not 4. This is 2. Total electrons is 10. Electron pairs is 5. This is how we're going to place this one. Carbon is 6 now. So this is 1s2, 2s2, 2p2. Valence electrons is 4. That is the mistake that I have done. Then we can place the carbon and hydrogen. Then bond pairs will be placed like this. Then each bond pair will be placed on top of these carbon atoms, because the remaining two will be placed like this. Then if you consider the formal charges, here we have placed 1, 2, 3, 4, formal charge is 0, 1, 2, 3, 4, formal charge is 0. So there is no formal charge on top of each carbon atom. But if you consider the electron octet fulfillment, electron octet is not fulfilled in each of these scenarios, right? So if you consider this carbon atom has only 6 electrons. This carbon atom is having only 6 electrons. So we are prioritizing the electron octet compared to the formal charges, right? We are neglecting the formal charges. We are prioritizing the electron octet fulfillment, right? So there will be some intermediate thing. We will place a kind of a dative bond towards this direction, from this one to from first carbon atom, second carbon atom, hydrogen, carbon, then there will be a double bond in between. So the formal charge here will be, this is +1, this is -1, right? Then we can place another dative bond towards this direction, from second carbon atom to first carbon atom. Then we will have something like this: carbon, hydrogen, carbon, a triple bond in between, like this. So again, the formal charges will be 0. If you check the total number of electrons around the carbon atom, it will be 8, right? So this is how a triple bond is created. Then electron dot dash diagram will be something like this. Lewis dot dash diagram. So this is C2H2. This is called as ethine, right? So this is the Lewis dot dash diagram, and how we build up the Lewis dot dash diagram for ethine, C2H2. I will give you some time clear this one. Huh? These kind of questions may be asked in the examination as well, like in term test or something like that. Then the next one is OF2. Central atom should be oxygen, not fluorine. So valence electrons from oxygen, that is 6. Valence electrons from fluorine, that is 7 into 2. So altogether 6 plus 14, that is 20. So E pairs, let's say this is total electrons, then E pairs would be 10. So we can place like this: oxygen, fluorine, and fluorine. One and two. We have to place the electron pairs. Starting from the most electronegative element in the terminal atoms, it is fluorine. 2, 3, 4, 5, 6, 7, 8. Other two will be placed on top of oxygen atom. Now let's count the formal charges. Fluorine is -1. Here also -1. Oxygen +2. Sorry, oxygen 0. Sorry. All are 0. Very sorry. Fluorine is 0 because we have placed 2, 3, 4, 6, and 7. Here formal charge is 0. Here also 0. Oxygen we have placed 1, 3, 4, 5, and 6, right? So this is also formal charge 0. So the formal charges will be 0. This is there is no requirement for the adjustment. Then the Lewis dot dash diagram will be something like this. You need to place the lone pairs as well. 3 lone pairs here, 3 lone pairs here, and 2 lone pairs on top of oxygen. This is OF2, very rare one, OF2. If there are any questions, you can ask from me. Huh? And the next one, H2O2. This is pretty special one. Here there is no valence, sorry, the central atom actually. We can start from valence electrons from oxygen, that is 2 into 6. Then valence electrons from hydrogen, that is 1 into 2, that is 2. Then total number of electrons, that is 14. E pairs, 7. Now how we place this one? Hydrogen cannot create a double bond. Oxygen can create double bond, so I will place like this. Final one is hydrogen. Then placing the bond pairs like this. We have placed 3, 4, and 5, 6, and 7. You calculate the formal charges. Hydrogen 0, oxygen 0. We have placed, if you can check, 2, 4, 5, and 6. So for each oxygen atom, we have placed 6. That means formal charge should be 0, right? Okay. Then the Lewis dot dash diagram would be hydrogen. So single bond here, oxygen and hydrogen, 2 lone pairs on top of the oxygen atom like this. H2O2 is a special molecule. This is called as hydrogen peroxide. Hydrogen peroxide, right? This is H2O2. You can take down this one, okay? Then SiCl4, right? SiCl4. Central atom should be silicon, right? So valence electrons from silicon, that is 4, because silicon is in 14th group. Valence electrons from chlorine, that is 7 into 4, that is 28. Total electrons, that is 32. E pairs, that is 16. Okay. Then we can place them: silicon, chlorine, 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 and chlorine, and the bond pairs like this. Then electron pairs placing. 4 has been consumed for the bond pairs, then the lone pairs. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. All has been placed Chlorine has placed 7 electrons. Formal charge is 0. Here it is 0, 0, and 0. Silicon also we have placed 4 out of 4. That is also 0. So silicon Lewis dot dash diagram would be like this. Now we know to find the shape as well. The shape should be tetrahedral like this because there are no lone pairs. Lone pairs are 4. So shape would be tetrahedral. So this is the Lewis dot dash diagram for SiCl4. If there are any questions, you can ask me. I have opened the chat window as well. Let's go to the next one. COCl2. Obviously, the central atom should be carbon. So valence electrons from carbon, that is 4. Valence electrons from oxygen, that is 6. Chlorine, that is 7 into 2. So all together 4 plus 6 plus 14. This is 24. This is total electrons. Then E pairs 12. We can place like this: carbon, oxygen, chlorine and chlorine. Bond pairs 1, 2, and 3. Then placing the lone pairs, we have to place 9, 3, starting from the most electronegative element, that is from oxygen. 3, 4, 5, and 6. 7, 8, 9, 10, 11, and 12. Then the formal charges. The formal charges, carbon, chlorine is 0 because we have placed 7. If you can count the number of chlorine atoms that is placed, that is 7. Here also 7. But when it comes to carbon, we have placed only 3 electrons. So this is plus 1. For oxygen, we have placed 7 electrons, right? 3 lone pairs and 1 electron in the bond pair. That is also belongs to oxygen. So there are 7 electrons. So this is minus 1. Then our regular thing, we can do a reactive bond structure, something like this. Then we can create a double bond in between these two. 2 lone pairs will be here like this. And chlorine, 1 bond pair, and 3 lone pairs like this. Here also chlorine like this. So the Lewis dot dash diagram would be C double bond O, the lone pairs, MCl and Cl. The Laban Sati paper, I will give you the structures as well, the shapes as well. So you can reduce the shape and as well as Lewis dot dash diagram as well. If you could do the statements, correct statements to find the shape, you will get the answer for this one, trigonal planar. Right. So for the paper, this is not needed, but for your answer sheet, the other answer sheet right? So here, trigonal planar, the Lewis dot dash diagram, there would be a double bond in between carbon and oxygen, and single bonds for each of carbon chlorine bond. Placing the formal charge is very vital. Then the next one is XeOF4. XeOFO, right? There was a question in the class as well. Xenon is in the 18th group. So the valence electrons, total number of valence electrons is 8 there. You have to take 8, right? So it should be the central atom. Valence electrons from xenon, that is 8. From oxygen, that is 6. From fluorine, that is 4 into 7. That is 28. So total electrons 28 plus 14, that is 42. Quite a high number of electrons. I think I have not done a mistake here. Yeah. So electron pairs will be 21. Let me check whether I'm correct or wrong. Yeah, that's correct. Yeah. So we can place the atoms like this. Oxygen, fluorine, 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 and fluorine. Then the bond pairs 1, 2, 3, 4, and 5. The lone pairs placing starting from the most electron negative one, that means with fluorine, right? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The remaining one should be on top of xenon, right? So the formal charges, fluorine 0, 0, 0, 0, because we have placed 7. Xenon, we have placed 1, 2, 3, 4, and 5, 5 and 6, and 7. We have placed only 7. So xenon would be plus 1, right? So let me revise the things. Xenon we have placed only 7, so this should be plus 1. Oxygen we have placed altogether 7, there should be minus 1 then here. We can do our bond, dative bond structure like this. So the Lewis dot dash structure would be here, double bond O, fluorine, 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 and fluorine. There would be lone pair on top of xenon, 2 lone pairs on top of oxygen, 3 lone pairs on each of fluorine like this. You can turn to your books and find the shape as well for this one. So this is 5-1. You can find the shape as well. This is square pyramidal, right? Not square bipyramidal. This is square pyramidal. So the shape is also can be identified. Electron arrangement around the central atom is octahedral because there are 6 bond pairs and lone pairs together. Right. Yes. So paper paper is over from here. I will take this time, there is some spare time for this one. I will take this time to draw the Lewis structures of N2O4 and N2O5. ගිය පාර පන්තියේදී මට ගිය පාර online class එකේදී මට කරන්න බැරි වුණා because of the time limitation. I will take this time to draw N2O4 and N2O5, right? There was a question as well whether whether it has been correctly drawn or not, right? So N2O4 valence electrons from nitrogen, that is 5 into 2, this is 10. From oxygen, that is 6 into 4, that is 24. Then we can say total electrons 34 total valence electrons. Then electron pairs 17, right? Then we can place the atoms like this. Try the symmetric nature when you are placing the atoms in a molecule, because always nature try to be symmetric as much as possible, right? So I will place the atoms like this: nitrogen, oxygen, 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 and oxygen, like this. So this is symmetrical, fair enough. I will place the bond pairs 1, 2, 3, 4, and 5. Then I will be placing remaining 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Right? Then the formal charges. Right? So the formal charges here it is -1. Here also it is -1. Here also -1. Here also -1. Because we have placed 7 electrons on top of each oxygen atom. When it comes to nitrogen, this is +2, and this is also +2, because we have placed only 3 electrons for nitrogen, each nitrogen atom. Then I can do a dative bond structure, something like this, right? From each of the oxygen atom towards the nitrogen atom. Then we have something like this: double bond N, single bond, double bond NO, and O a lone pair, sorry, dative bond, sorry, the bond pair. Here we have 2 electrons here, 2 lone pairs, 2 lone pairs, and there will be 3 lone pairs like this. Right? Now the formal charges would be here +1, -1, +1, and -1. If you closely check, the electron octet has been fulfilled in on top of each nitrogen atom. If you check, like here we have 4, 5, 6, 7, 8. Right? Here also 8. Nitrogen cannot go beyond the electron octet. So therefore we have to stop from here. We have to keep these formal charges. All right. So the Lewis dot dash diagram would be oxygen double bond N, single bond N, double bond O, O, single bond O. Here it would be +1. Here also +1. Here we have -1. Here we have -1. You have to place the lone pairs like this. Actually, what has happened is a dative bond has been created between each of the nitrogen atom and the oxygen atom, which I have drawn in below. That means in between these two, a dative bond has been created. That is what has happened. That's why the formal charges on top of each atom, right? So that is the analysis part. It is coming from our Lewis dot dash structure nature or during our process, right? So this is how you write or how you draw N2O4. කිරි ප්‍රශ්නවලට නිතරම අහන දේවල්. එහෙම නැත්නම් term test එකට මේ වගේ දේවල් වලට අහනවා. After this one, I will be going towards more complex Lewis dot dash structure drawing, right? So these are a little bit of medium level one, in the medium level hard when it comes to the difficulty, medium level difficulty. But there are some complex structures that you need to draw the Lewis structures. I will start that one from tomorrow onwards. Ita class එක තියෙනවා. ඊට මම අමාරුම අඳිනවා. Right? Then මේක හඳගන්නකො. Yeah, I will give you some time for this one. Then let me go to the N2O5, right? With the gear para mangar ගෙදර වැඩද්දී මම මේක කරන්න බැරුණා මට, right, because of the time limitation. N2O5, let's try to draw this one. Then we can say valence electrons from nitrogen, that is 2 into 5, 10, that is from oxygen, that is 5 into 6, that is 30. Then total electrons, valence electrons, 40, E pairs 20, right? Then placing the atoms, follow the symmetric nature. I will place like this: nitrogen, oxygen, oxygen in the middle, like this. So this is how we're going to place N2O5. Then the bond pairs 1, 2, 3, 4, 5, and 6. Then placing the lone pairs 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? Then the formal charges -1, -1, -1, -1. Here it is 0, because on top of oxygen we have already placed 2 lone pairs, that is 4, and 1 electron from each bond pair, that is 6. So altogether there will be 6 in the middle oxygen atom. Then the formal charge would be 0. When it comes to nitrogen, we have placed only 3 on top of each nitrogen atom, so there will be +2 charge from here and here, right? Then a dative bond structure like this. Then I can create something like this. Then there will be a double bond here like this, and a single bond nitrogen, oops, single bond nitrogen, double bond here, and a single bond with the lone pair. So +1 charge on top of each nitrogen atom and these oxygen atoms. This is because it has created a dative bond in between these two, right? So this is the correct structure for N2O5, Lewis dot dash structure, right? So this is for N2O5. මම හිතනවා මම පන්තිදී කරලා ඉතින් 30කට ආසන්න ලෙවිස් ඩොට් ඩෑෂ් ස්ට්‍රක්චර්ස් අඳිනවා. කොහොම මම තනියම කරලා මේ පුතාලත් එක්ක මම කරලා තියෙනවා. මොකද එතකොට විභාගයට එනවා ඉඳලා පුළුවන්. හිටින් ඉඳන් මම complex structures අඳින්න පටන් ගන්නවා. I'm going to start to draw the complex structures. How to draw the Lewis dot dash diagrams for the complex structures. හිට රෑ පන්තියේදී මම ඒවා අඳිනවා. right? හෙට පන්තියේදී. එතකොට හැමෝම ඉන්න ලයිව් සෙට් වෙලා මොනවද ප්‍රශ්න තියෙනවා නම් ගණන් හදනකොටම ප්ලේට් ක්ලැරිෆයි කරගන්න පුළුවන්. මම රෙකෝඩින් එකක් දෙනවා, but I encourage you to join for the live class. So හෙට ක්ලාස් එකේදී Lewis dot dash diagrams මම complex ඒවා වගේ අඳින්න පටන් ගන්නවා. ලොකු ඒවා වගේ. හරි. වඳින්න කොහොමද කියන එක මම step by step මම කියලා දෙනවා. right? So therefore join for the class tomorrow as well. Then there is some announcement here. One announcement is like in the about our August month plan. I have shared some the document as well with you on the group. අපේ classes ටික තියෙනවා regular time එකට. There will be some extra classes, 3 extra classes on Wednesdays. I will announce you the dates, right? I will announce you the dates soon. So there will be 7 classes for August month, right? So my target is to complete both the units, unit 3 and unit 2 within August. එතකොට අපි September මාසෙදී අලුතෙන් gaseous පාඩමත් එක්ක තමයි පටන් ගන්න. That is the plan. පොඩි deviations වෙන්න පුළුවන්. but right now this would be the plan, right? So for today, that is this is the end of the class. Tomorrow also we have the class at 10 p.m. Right, tomorrow also we have the class at 10 p.m. Then we will meet tomorrow as well. Right. Okay. Good night. Thank you.